sample of fruit, so a sample of fruit juice has a pH of 6.0. What is the concentration in mole per dm cube of hydroxide ions? Okay, and now looking at this question, you're going to know that in fact, you're not going to use a scientific calculator to solve this. Neither are you going to use a log table to solve this. Now, what do we do? I'm going to show you how to solve this kind of question without using a calculator or a log table. Now, what do we do? Now, solution. I'm going to divide this board into two so we can have space. Okay. Now, the first thing is this: we have formulas regarding to P. This is a question regarding to what? pH scale. Okay, pH scale. We are talking about the measurement of the degree of acidity or alkalinity of a substance. So we say pH plus pOH is equal to 14. We have pH is equal to minus log in concentration hydrozonium, or we can say minus log hydrogen ion. Okay, or we can also say pOH is equal to what? Minus log OH minus. And please, whenever you see this kind of question, this bracket here you're seeing here is the concentration. Okay, and now the question says a sample of fruit juice has a pH of 6.0. What is the concentration in mole per dm cube of hydroxide ion? Okay, of hydroxide ion. You understand? So what do we do then? We're going to pick a formula that suits this question. So what do? We have to find the concentration in mole per dm cube of hydroxide ion. So first thing, what do? pH has been given to us and we don't know our pOH. So we're going to use this second formula here that says pH is pH plus pOH is equal to 14. So what do? Our pH given to us here is 6.0. 6.0 plus pOH is equal to 14. So our pOH is equal to 14 minus 6.0. Okay, 14 minus 6.0. pOH is equal to what? 14 minus 6.0 is what? 8.0. And if you look at the option here, we have A 1.0 times 10 to the power minus 5, 1.0 times 10 minus 8, 6.31 times 10, 8.0. But that's not the final answer. The final answer says, what is the concentration? What is the concentration in mole per dm cube of hydroxide ion? That is this hydroxide ion. We've gotten our what? pOH, right? Now to solve further, what do? We say pOH is equal to minus log OH. Okay, and now what do? pH is given to us as what? 8.0 is equal to minus log OH given. Now what do? To make this the solid of the formula so we can get our OH, we're going to make minus log OH as the solid of the formula. Then we take this one. When you're now crossing this one over, this one takes a negative sign, this one takes a positive sign. So what do? It becomes log OH minus is equal to minus 8. And to do this, what do? We need to look for the antilog. To do this, we need to look for the antilog of minus 8. And note in this point now, so we're going to look for the antilog. Look for the antilog of minus 8. And note, we don't have calculator, we don't have logarithm table. So what do? Now it's very simple. What do? We know that antilog means 1 inverse of log, right? So what it simply means is this. So let's look for our antilog of minus 8. For instance, let me just show you. For instance, you have to look for the antilog. Find the antilog of 2.5. Now what it simply means is this. It means that it's going to be 10 raised to the power 2, because if you check this on the log table, it's between 2 and 3. It's what? 2 and 3. So it's going to be 10 log 10 raised to the power 2, and also what? 10 raised to power 3. And now using your indices form, what it means is this: we have 2 plus 3 give us 10 raised to power what? 5. Okay, and when you get this, it becomes, now to get the antilog means you square 10 raised to power 5 is equal to 10,000. Sorry, 1 2 3, sorry, 1 2 3 4 5, that's 100,000. And when you do this, you have 3.162. okay, now using the same understanding, now we are asked to look for the antilog. We are asked to look for the antilog of minus 8. Now what it simply means is this. It means you put 10 raised to power minus 8. That's what it simply means. So 10 raised to power minus 8 is simply the same thing as saying as 1 over 10 raised to power what? 8. Okay, and what it means is this: 1 divided by 10 raised to power 8 is, that's 1 0 into 8 places, 1 2 3 4 5 6 7 8, and when you divide this, you're going to have 0.1 1 2 3 4 5 6 7 8, then 1. And when you convert this to standard form, you have 1.0 times 10 raised to power what? Minus 8. Okay, that is what it simply means. Okay, so when we check for our options with our calculator, you have 1.0 times 10 to the power minus 5, 1.0 times 10 minus 8, 6.3 times 10 minus 5, D 8.0 times 10 minus 5. The answer is what? 1.0 times 10 minus 8. This is B. And please take note, like I said, understand the question before you solve. He said a sample of fruit juice has a pH of 6.0. What is the concentration in mole per dm cube of hydroxide ion? So looking for the concentration. This is the main question. So when you get your pOH, you now get the concentration itself. That's what we did there using this formula. Then we say pOH is equal to what? Minus log in concentration of what? Hydroxide ion. Okay, now we have the second question here. It says balance and identify the nuclear pause. Okay, we have the second question here. It says balance and identify X in the nuclear equation. Now we have 14. This is a question, and we ask what? Balance and identify X in the nuclear equation. So what do we do? Solution. I believe we've seen something like this before. This is called a nuclide. Okay, and where A is equals to mass number, then Z is equals to atomic number. Okay, now with this understanding, we're going to say let X, that's this S now, let S be represented as AZ, where A is a what? Mass number, and Z is a what? Atomic number. So from this thing, we're going to what? To solve this, to balance and solve this, you're going to first of all, you're going to consider the mass number. That's the mass number. We're going to consider the mass number of both sides. And that is, we have the mass number of N, that's 14. Okay, 14 plus mass number, okay, A. 14 plus A is equal to 18. That's the mass number of this N and the mass number of fluorine. That's the mass number of nitrogen and the mass number of fluorine. Okay, we're going to consider them. So A, so I will say that, when we do that, we say A is equal to what? 18 minus 14. So the mass number for this is equal to what? 4. Now the second step is this. We're going to consider, sorry, We're going to consider the atomic number of both sides. Okay, now the atomic number is this number here of both sides. So we have 7 plus z is equal to 9. Okay, that's this one is to this one. So we have as z is equals to 9 minus 4, right? Sorry, 9 minus 7, as z is equals to what? 2. So therefore we're going to balance we say az is equal to, so our a here, that's our atomic number gotten is what? 4. And the mass number gotten, that's a, is equal to 4, and our atomic number z gotten is equal to what? 2. So therefore it becomes 4 subscript 2. Okay, that's 4 representing the mass number and 2 representing what? The atomic number. So from the option given to you, we have A, we have B, we have C, we have D. The answer is equal to what? B. So these are answers. So we're going to stop here, and we have to identify X in the nuclear equation. Now this nuclear equation is an alpha particle equation. Okay, so maybe in our next class I will tell you how to solve for alpha particles, beta particles, and what? Gamma particles. Thank you for watching. Thank you for being with us. Subscribe, like, and comment. Thank you. Bye.